Good morning, calc fans. How are you doing on this fine, sunny Monday morning? A little chilly out there still, but the weatherman said it's going to get a little bit warmer. It's sunny out. Maybe get an opportunity to get yourself outside and get some do some things on the outside, get some fresh air a little bit. I hope everybody's doing well in your household and you're doing well. Also, please do remember to keep your social distancing. It's out there. They say it is working and it is helping. Do our part in regards to trying to get ourselves back to normal. I miss you guys. I wish you were in classroom right now, but it is what it is. It's our reality. Today we're going to continue to work with Riemann sums. There'll be some sort of quiz this week. We're going to deal with you had the left sum, right sum, all the Riemann sums in regards to estimation and approximations. Now we're going to last week we looked at some sigma. And some stuff that we did for pre-calculus. Today we're going to look at some sigma rules, properties of sigma that could help us out in regards to finding a solution and finding the solution to a series of terms. Okay, when we talk a lot, take a look at some sigma properties here. Maybe. If I have some constant times n to the 8th power, okay, and my variable, it does not matter what my variable is, what I'm able to do is I'm able to take this constant and move it out front. So I have a constant times the sigma of n to the a. And likewise, when I come over here, if I go from n to k, and I'm trying to find values here, and these are all properties of sigma, I could go my constant times n to the a power plus my sigma of d. So I can break these apart into different little increments, and this will be useful when we utilize our properties here in regards to sigma. And these properties you'll be able to have access to. I'll make sure that you have access to them, or you can look at your notes in regards to it, because I'm not going to ask you to memorize these properties. But we have constant times n to a. Whenever I can have a constant, I could just move it out in front of my sigma, or I could just have a sigma of a constant. We'll take a look and address all these situations that we have here. If I take a look at a sigma of just a constant, I have n is equal to 1 to a value of k. So I have a constant here, and I only have a constant. So my first term, this is when n is equal to 1, I have the constant. N is equal to 2, I have a constant. N is equal to 3, I have this constant. So I have this constant, and I'm just adding up the number of constants, and I'm going to add up k of these constants. Well, if I take a look at my properties, I can look at, well, I have c plus c plus c. Well, if I just add these two together, if my k was 2, I would just have 2c, or if k is 3, I'd have 3c. If k is 4, I would have 4c. Or what we can simplify this into is we could just multiply our k value on top times my constant. Because all we're doing is we're adding up k number of c's. We're adding them up. I can simplify that into a multiplication problem. So I have k times c. So when I have a sigma of a constant, I can calculate this by c times k. Well, suppose I have a value of just n to the first power. So if n is 1, I get 1, n is 2, I get 2, n is 3, I get 3, n is 4, I get 4. Really, I have an arithmetic series here. I have an arithmetic series with a common difference of 1. And this will go all the way up to k. We can calculate this series by taking k times k plus 1 all over 2. So whatever our k value is, I can multiply by k plus 1 divided by 2. This basically is a simplification of, if I was dealing with my arithmetic series, the sum of an arithmetic is my first term. The sum of my first term the average of my first and last term and multiply it by my total number of terms. If I would take this and simplify this down, I would get the k plus 1, because this here is my first term, this here is my last term. So my first term is 1, my last term is k, and I divide that by 2, and then multiply it by my total number of terms, which is k. So really what this would transfer into is what this is k times k plus 1 over 2. This is the average of my first and last term. Average of my first and last term times my total number of terms. Or if I just have some value of n, I have k times k plus 1 over 2. Now, if I put a constant out front, all that does is that moves I have c times n. I can bring the c out in front of my sigma. So what this simplifies down into then is c times k plus 1 all over 2. Basically, it just takes this and multiplies it by the value of c. So when I have a coefficient in front, I just bring the coefficient out front. Now these are easy to deal with here because we can always transfer these back into the arithmetic sequence that we've dealt with. Okay, so this is something that we've already dealt with. It's just a different way of looking at it. But what we started having trouble calculating the sum of is, well, if we had n squared. If I didn't have an arithmetic and I didn't have a geometric series, how can I calculate my series? How can I calculate my series when I have an n squared there? Which was one of the ones that we had the other day, 1 plus 4 plus 9 plus 16. It's not arithmetic, it's not geometric, so how do I calculate that? Well, the only way we had to calculate that is adding up and putting in a calculator, 1 plus 4 plus 9 plus 16 plus 25, but what if you have 500 terms there? You're not going to want to do that. Well, what this simplifies down to is if I have the perfect squares here, or if I have n squared, we can calculate our sum by taking k times k plus 1 times 2k plus 1 all over 6. And once again, I'm not going to ask you to memorize this. Okay, you can take a look and write it down so you have it there, because I don't remember it. I don't remember when I have a square term in the sigma for my square terms. I don't remember that, so I have to take a look and look it up. So you can also look it up also, or have it there on a piece of paper and refer back to it. So I take my k, which is my top value, times k plus 1 times 2k plus 1, all divided by 6. And likewise, when I have a constant times n squared, so if I had like 3x squared or 3n squared or 5n squared, 7n squared, if I had something like that, I can just move my constant out front and just multiply my value by the value of c. So we have c, k plus 1, k plus 1, 2k plus 1 all over 6. So that's how I could do my square, my series and my sequence of my square terms. When I have n cubed, so I have the cubes here, 1 plus 9 plus, or 1 plus 8 plus 27 plus 81. Once again, it's not arithmetic, it's not geometric. How do I deal with this? And if I'm going too fast, once again, hit your pause button and you can catch up. So if I have the perfect cubes here, if I want to find my series of my perfect cubes, this is equal to, maybe, k squared, k plus 1 squared, all over 4. So whatever my top value is here, I square it, add 1, I square it, and I divide by 4. And that would give me the sum of my terms that I have here. And likewise, when I have a constant out front of that, I just multiply this by the value of c. So if we take a look at some problems here. If we take a look at some problems. I have the sigma of 1 to 19 of 5n squared. Well, I have an n squared term here. It's not arithmetic, it's not geometric, but I want to find my series. So how can I find the series? Well, I can first move my 5 out front. And And mind you, and one thing I'll also note to you, you need to start this at a value of 1. If this starts at a value of 2, then I would have to move this down to 1. I'd have to subtract 1 from that also. So you need to get this at a value of 1. So I have 5 times the sigma of n squared, from n equals 1 to 19. Well, if I take a look at my formula for n squared, this is my k value at the top. Looking at my k squared, or my n squared, we take our value of 5, multiply it by my k, which is 19, times k plus 1, which is 20, and then 2k plus 1, so we have 2 times 19, which is 38, plus 1, that's 39, all divided by 6. So I can clickety-clack do my calculator. Get my calculator out here. 5 times 19 times 20 times 39 divided by the value of 6. And we get 12,350. 12,350. If I take a look at 7n cubed, once again I can rewrite this as 7 times the sigma n equals a 1 to 41 of n cubed. So my n cubed, I take a look at what we have here. My k value, my top value, my k value is a value of 41. That's my top value. So we take our 7 times, we have k squared, which is 41 squared, and then 41 plus 1, which is 42 squared, and divide this by a value of 4. Not very difficult stuff to do, it's just a matter of realizing it's there. 7 times 41 squared times 42 squared divided by 4. Oh, really big number, 5,189,247. Now I'm going to change this problem just a little bit. Suppose I start at n equals 3 and I go to 33. What we need to make sure of when we're dealing with this is that we start with a value of n equals 1. Well, if you start with a value that's not the value of 1, what you have to do is you have to be able to take it back to the value of 1. Well, to take it back to the value of 1, I can subtract 2 from this. If I subtract 2, I get back to my k, n is equal to 1. But what I subtract from here, I must also subtract from here. And that would take me back to a value of 31. So when you don't have an n value of 1, just subtract to get it back to a value of 1. But now what we have is we have 2 terms here. So we have the sigma, oopsie, seven times sigma of n plus the sigma of 5. And this is n equal to 1 to 31, n equal 1 to 31. What I tend to do when I have a couple terms there is I usually do them separately. I can write it out like this, but I'm just so it keeps it straight in my mind when I'm dealing with here, and I don't get confused. We have 7 times the sigma of n from 1 to 31, and then we have the sigma of 5 from n equals 1 to 31. So what I can do is I can just do each one separately, but then I can add these together. Well, looking at the top, when I have a variable here, just a variable, I have k plus 1 divided by 2. So we have 7 times k plus 1 divided by 2. When I have just a constant, I just take my constant times my k value. So I have 5 times my 31. This is 31, this would be 32. So I can find a value. 7 times 31 times 32 divided by 2. We get 3472. And then I have 5 times 31, which is 155. And we can just add these down. So we have a value of 3627. Okay, what I want you to do is I want you to split these two apart and work this one on your own. And then come back. I want you to turn your video off, work this one on your own, turn it back on, and check your answer at this point. So what we have here is we have 8 times the sigma of n squared, n is equal to 1 to 27, plus 3 times our sigma, n equals 1 to 27 of a value of n. And once again, I usually work these independently and just add down my column then. It keeps a little bit straighter in my mind so I don't get confused. When I have n squared is k plus 1, 2k plus 1. My k is a value of 27. So we have 8 times we have k, which is 27. 27 plus 1, which is 28. Times 2 times 27 plus 1. Well, 2 times 27 is 54. Plus 1 is 55. And this is all divided by 6. Once again, this is k plus 1, 2k plus 1 divided by 6. And then when I have my n, I have 3 times k plus 1. So we have 27 times 28 divided by 2. Once again, that's k plus 1 divided by 2. So I have 2 click-clacks I have to go through. We have 8 times 27 times 28 times 55 divided by 6. We have 5,000 or 55,440. And then we have 3 times 27 times 28 divided by 2. We get 1134. And we can add those together to give me 56,574. Oh yeah. There we go. Boom, boom, boom. Oh yeah, that's what I'm talking about here. We have adding these two together to come up to our value. Once again, dealing with sigma rules for our polynomials. When it's not arithmetic, it's not geometric, this is what we have to do to find our series. I will post a worksheet for you to work on, continue to work through these. And once again, expect evaluation sometimes this week. We'll start pulling things together here and get an evaluation sometimes this week, and also an in-class assignment. Please do keep up with the material as we get through it. We still need to get through the material for the University of Findlay. We still need to be able to get through this material so we can get you a grade. If you have questions, please comment me with your questions. Other than that, I have nothing else for you today. Enjoy the sunny, warm day today. I miss you guys. I wish you were in classroom. I wish I was sitting here watching you guys play euchre the last 5 minutes of the class, but it's not there. So this is our reality. We will continue to do the best we can with what we have. Other than that, I have nothing else for you. Adios. You folks have a great day.